In this video, we'll find the volume of this concrete, of this fountain area. The middle is just has a radius of x, and then you've got a 2-foot thick wall, and it's also 3 feet high. So let's talk about the volume of a cylinder first. Okay, a cylinder like this, if you've got H and you've got R, then the volume equals pi r squared times H. Okay, so now let's talk about this. Let's first find the volume as though it were all concrete. So it wasn't, let's say it wasn't empty in the middle. In that case, the R would be x plus 2, right? That's the radius, x plus the 2. The height would be 3 feet. Okay, so let's do that. Let's do the volume as though it were all filled in, without the hole, like a donut without the hole taken out. So you've got pi. Instead of r, we're going to say x plus 2, quantity squared, times the 3, times the height. Okay, got it. But we are going to subtract this middle part, so I'm going to put that in red. We're going to subtract this donut hole. So the volume of that, the volume of the middle, equals pi. R, the radius, is x, so I'll have x squared, times, now the height is still 3. Inside there, the height is 3. So times 3. Let's put parentheses around that so we can see that a little bit easier. In this video, we're going to be finding the volume of just the concrete area here. This is like a donut. So you've got a concrete wall that's going to be empty in the middle because it's got just water in the middle. So the volume of the concrete. Well, first, this is a cylinder. So let's take a look at the volume of a cylinder. Here's a cylinder like a can. You've got a radius and a height. That's the height here. The volume of a cylinder is pi times the radius squared times the height. Okay, so let's find the volume of this entire donut. I'll talk about it like a donut because it's kind of easy to visualize a donut with a hole in the middle. We're going to talk about a donut that it's a solid donut. The hole is not taken out yet. So let's talk about the whole thing. No hole yet, just the whole thing. With the whole thing there, we have the radius equals x plus 2. That's our full radius here of the whole donut. That's W-H-O-L-E, not H-O-L-E. Pardon the pun. The height is 3 feet. Okay, so the volume of the whole thing, as though the hole were not removed, the whole thing would be volume equals pi times the radius, and that is x plus 2, squared, the radius is being squared, multiplied by the height of 3. Okay, got it. Let's hold that for a second. Let's now subtract this middle area. So we are going to take the hole out of the donut. The radius there equals x. Of course, the height is still 3. That's for this middle part. So the volume of that middle part, the part that's being taken out, is pi times the radius, is x squared, times the height of 3. Okay, so if we just want the volume of the donut without the hole, or that is the volume of the concrete here, we're going to take the entire volume minus the volume of what has been removed here. Okay, let's do it. Volume of the total thing, that's pi times x plus 2 quantity squared times 3, that's from this first part, minus the second, minus the whole, the volume of the whole, pi x squared times 3. Okay. That's it. We can clean this up a little bit, but that's the answer. So let's factor out a pi and a 3. I'm going to do a few things here. So 3 pi, I'm factoring that out. And then in here, I'm going to multiply x plus 2 quantity squared. That's going to be x squared plus 4x plus 4 minus this x squared. And I better put brackets around that. So I've factored out, let's put some color around here. I factored out the pi and the 3 right there. And then what was left was x plus 2 quantity squared. Let's put some color there. X plus 2 quantity squared, that was this. Minus still the x squared. So let's put a little color there. And it's minus because there's a minus there. We can clean this up a little bit more. X squared minus x squared is going to be 0, so I'm going to have a 4x plus 4 left in there. So I can show that. V equals 3 pi times 4x plus 4. Now, if the answer in the book gives it something like that, it could do that, or it could distribute that 3 pi. So I'm going to circle this. That's one correct answer. You could also distribute that 3 pi. You could say that the volume equals 3 times 4 is 12, so that's 12 pi x, and then 3 pi times 4 is 12, so 12 pi. I don't think the book, usually books like to leave it factored like that, but it depends on what the answer key writers were feeling like that day. Okay, that's it. That's finding the volume of this. And again, it's like finding the volume of the full thing minus the volume of the whole. And that's all we did. All right, I hope that helps.